Now, instead of having two moving walkways, we're going to have one giant moving walkway. That giant moving walkway is going to be moving to your right. We are going to run northward on our moving walkway. So, I've identified this as a vector. The way we can identify a vector is by putting a little arrow symbol over the top of the letter. So I've identified vector A. Vector A is how fast we are going to be moving. We're going to run at 5.0 meters per second north. In the textbook, they will sometimes identify a vector using a bold symbol, like put the letter in bold. It's hard for me to do boldface on the board, so I always do the little arrow above the symbol. The moving walkway is going to be moving at 10.0 meters per second east. So this whole moving walkway is going to be moving to the right at 10 meters per second. So that is vector B. Vector A looks like this. Again, in front of you, there is a moving walkway moving this way at 10 meters per second. You are going to attempt to run this way at 5 meters per second. For a moment, think about what direction you are actually going to go and point in that direction. Okay? You're not going to be moving this way. You're going to be moving at an angle, something like this, right? This way. As you try to run this way, the moving walkway is going to carry you this way. You're going to be carried down people mover, down moving walkway. And the way we illustrate that is by drawing this. This is our resultant vector. So our resultant vector R, which is equal to vector A plus vector B, is what we're trying to find. And this is called the resultant vector. It is the result of the addition of vectors A and B. It is going to be our resultant velocity, the net velocity from this motion. Okay, resultant vector. Okay. How are we going to find the resultant vector? Susan?
The vector you're moving at and the vector of the
people mover. So we're going to add 5 plus 10 and get 15.
Yeah.
We're actually not going to do that because that would not include the direction. Notice that the direction matters, right? We had 5, 5, and 5. But if I was running on this one, it was 5 plus 5. If I was running on this one, it was actually 5 minus 5. So notice that the direction matters. We need to include that. How are we going to find the resultant vector here? Tish?
Would you do a squared plus b squared equals c squared?
The Pythagorean theorem. A squared plus b squared equals c squared. What is it about this triangle that says that you can use the Pythagorean theorem? Rachel?
It's a 90-degree angle because north and east are 90 degrees.
North and east are 90 degrees to one another, which makes this a right triangle. Remember, you can only use the Pythagorean theorem when you have a right triangle. So we have the resultant vector squared is equal to the a vector squared plus b vector. So the resultant vector is going to be equal to the square root of a squared plus b squared. Or the resultant vector is going to be equal to 5 squared plus 10 squared, the square root of. And could I please have that number? $11.180.
3.
That's 180. Okay. In other words, the resultant vector is 11 meters per second. In other words, the resultant velocity is 11 meters per second. In other words, the resultant vector is 11 meters per second. David? We need direction. Remember, a vector has both magnitude and direction. It is not correct to say that the resultant vector is 11 meters per second. We could say the magnitude of the resultant vector is 11 meters per second. We know that our resultant speed is is going to be 11 meters per second. But we need to identify a direction. So we need to identify an angle. How are we going to find that angle, Mr. Carpenter, James? So? Yeah, how?
Sine equals.
Oh, good.
Sine theta.
Oh, good, you remember theta, that's good.
Equals opposite over hypotenuse.
Good. Opposite.
Opposite equals. Five.
Whoa. You don't want to fall down the stairs. No. Tina, help him out. He's falling down the stairs. He's skipping steps. This is not good. Arjun.
Vector B.
Theta then is going to be equal to the inverse sine of vector B over vector R. So we have theta is going to be equal to the inverse sine of B, which is 10, resultant vector 11.180. Theta then is equal to please.
63.4349.
4349? Okay. So, in other words, our resultant vector is 11 meters per second at an angle of 63 degrees with sig figs. And I'm going to say that is this angle right here, which means it's 63 degrees east of north. I will talk about the east of north in just a moment. Let me say a couple things first. So, this means that when we try to run at 5 meters per second north on a people mover, which is moving at 10 meters per second east, we will actually be running, our resultant velocity will be 11 meters per second at an angle of 63 degrees east of north. Okay. That's what that means. Now, we'll talk about the direction first. So, 63 degrees east of north. Before I talk about that, let's just talk about direction in general. There are those of you who are directionally impaired. True statement, yes?
Yes.
Okay. I am spelling impaired. We've established that. I move on, I'm okay with it, I do my best. For those of you who are directionally impaired, I suggest that you admit it, you move on, and whenever you work with vectors, you should draw a nice compass rose at the very top of your paper. In addition to that, do not turn the paper. Never turn the paper. This will confuse you. It confuses me, and I'm not directionally impaired. So always keep the paper vertically, draw one of those at the top. Now, let's talk about where I got 63 degrees east of north. Talk about a giant compass rose. North, south, east, west. The angle we got was this one right here. That angle right there. If you look at it, we can just put a small compass rose here. We have north, south, east, west. This angle right here is, and it's easier if you think of it as from instead of. That's what the of means here. So it is east of north because it is east from north. We're moving eastward from north. Eastward from north. That makes this one right here, Taylor, what? Taylor. Bless you. This angle right here would be north of east. What about this angle right there? What angle is that? Awesome.
Southwest.
This one would be south of west. What about this angle right here, please? Claire, this angle.
North of west.
This one would be north of west. This angle right here, Ezra,
East of south.
east of south. Katie, what about this one?
West of south.
This one is west of south. That angle right there. Christine? South of east, one left. This angle right here, please. Ginny? West of north. So you can see those are the 8 options when describing an angle. So coming back to our answer, we said 11 meters per second at an angle of 63 degrees east of north. We could have also written that a resultant vector was equal to 11 meters per second at what angle? There's an answer that is equivalent to 63 degrees east of north. Mike? 27 degrees north of east. You can describe this direction as either east of north or north of east, and it's just going to be 63 degrees minus the 90. So it would be 27 degrees. Let's return back to Susan's question, or Susan's answer to this question, which is, I just said the resultant vector is equal to A plus B, so we've got, that's 5 plus 10 equals 11. We just wrote on the board 5 plus 10 equals 11. I can do whatever I want, clearly. You guys aren't going to ask questions. Because 5 plus 10 equals 11. I don't know if you do that. Your shot.
5 plus 10 is not equal to 11.
Your shot. Thank you. Well, I feel better. But we just put 5 plus 10 equals 11, right? We have 5 plus 10 equals 11, right?
It doesn't take into account the directions.
If you look at it from in terms of just the scalars, just the magnitude of these vectors, it doesn't make any sense. Because of course, 5 plus 10 doesn't equal 11. But when you include the direction, this is vectors. This is how it works. This isn't 5 plus 10 equals 11. This is 5 meters per second north plus 10 meters per second east equals 11 meters per second at an angle of 63 degrees east of north. Without the directions, yes, it doesn't make sense because it would be wrong without the directions. These are vectors. You have to include the directions. So yes, 5 plus 10 does not equal 11.